Hello and welcome to another step video. I'm just going through this extension question here. Hello everyone. Okay, let's get on with it. Show that x minus 3 is a factor of this long, ridiculously long algebraic expression here. Sure, okay, I mean, factor theorem, that's straight away what I'm seeing here. That is a typical question. We're just putting it in an expression involving x's and y's. So it's a two variable expression rather than a one variable expression. But factor theorem still applies. It doesn't just work for p of x, it works for p of x and y or p of x and y and z. If you want to factorize a multi-variable expression, you can still do it using factor theorem. So what I'm going to do is I'm going to say let x equal 3, then, and I'm going to make it real clear to the examiner, I'm plugging 3 in, and I'm hoping, if it's a factor, that 0 is going to pop out. That's what I'm hoping. Now remember, the y's still remain as y's. Try not to make a mistake as this happens. I know I frequently do. Plus 18 plus 6y. Okay, so we're crossing our fingers at this stage. Okay, simplify a little bit, or maybe we should just try and actually cancel it down now. I do get somewhat impatient and I skip a lot of steps nowadays. But if you look, we've got 27, yeah, minus 45. Okay, so that's at minus 18, I think, plus 18, douche, douche, douche. So they cancel. Then we've got 2 times 9, that's 18y. And then we've got 6y on the end, but we've got minus 24y there, so they cancel. And then 3y squared minus 3y squared, it equals 0. Hence, x minus 3 is a factor. Yeah, you must write that down at the end. It kind of like, you're sort of nudging the examiner saying, I have plugged it in and I did check it equals 0. Yeah, because otherwise, people can kind of fudge their answers and stuff like that and pretend it equals 0. Yeah, make it clear, I know it equals 0. I checked it. It's almost like you're putting your guarantee on it. Okay, as a factor, maybe we'll call it what they've called it as well, of star. They called it star, didn't they? If you see that funny little symbol on the right, I quite like doing that. Like, they name equations. They, whether it's, whether you do it with letters or little symbols over here, it's a good way of doing things. Anyway, so far so good, yeah? So we know that's a factor, so we should be able to factorize it and get it multiplying by something else. Now, they've got two interesting brackets here. Firstly, they've got 3 terms in each bracket. That makes it more complicated straight away. But certainly, let's just try and find something which multiplies by x minus 3 to make this. Now, if you're in my class, you'll know that I very much like to use these little grids. I definitely don't approve of long division. I just find it really long. They don't call it long division for no good reason. It's long division because it's long. Okay, so what I'm going to do is I'm going to try and come up with something which multiplies to give what I have up there. Yeah, so clearly I need an x squared. And that gives me the x cubed, and it gives me minus 3x squared. Yeah, so I'm going to tick that because I've done it. Now I need minus 5x squared, and there's only one way I can get that, and that's by putting minus 2x here, giving me minus 2x squared, and now overall I've got minus 5x squared. That also gives me a 6x, which funnily enough I also needed. Good, so far so good. Now looking at this next, I need a 2x squared y, so I guess I'll need this to be 2xy to make 2x squared y. Great, I've got that now. It also gives me minus 6xy. Slightly disappointing because I needed minus 8xy. So maybe I should try minus 2y here. So I've got a minus 2xy there. So overall I've got minus 8xy. Good news, I can tick that. And I can tick the 6y on the end. Now, all I've got left is xy squared and minus 3y squared. Hope that everything works out at the end here. If it does, then you've done it correctly. If it doesn't, then something's gone wrong. But we need xy squared, so I'm going to put in a y squared there, and xy squared minus 3y squared. We have success. So we know now that x minus 3 multiplied by all of those terms, x squared minus 2x minus 2xy, no, plus 2xy minus 2y plus y squared is star. Yeah. Okay, let's try and turn it into the format they like. Essentially, they want this factorized into two distinct brackets. It's kind of well, two distinct linear brackets, and we've got some, powers of 2 in there. So we want to essentially do the same trick again. And that's what I'm going to do. Down here, I'm going to write down, okay, oh, you definitely want to keep an eye on what you're heading towards. Now, this is a bit kind of like, educated guessing, yeah? Notice that both of these x's have a coefficient of 1. So we need to start with x and x, yeah? They've told us that these start with x and x. We just need to work out what a, b, c, and d are in these equations. So we know we've got something times y and something times y there. Now, if you can see, we've got x and x. That gives us x squared, yeah? So that's kind of good. I suppose we need we need 2xy at some point. And also you can see straight away, look at this, b and d. Now, when you multiply out those brackets, b times d is just going to be the number on its own. Now, are there any numbers on their own in there? No. That tells me straight away that one of b or d must be 0, yeah? There can be an extra one in one of them, an extra number there, but one of them's got to be 0, basically. So that's all kind of like little hints for like your little investigation of what times by next. I suppose we could think, well, we need minus 2x there, but yeah, okay, let's try minus 2. Yeah, minus 2x. Okay, cool, we've got that one. So we've got x minus 2, but we really need to start finding these y terms. Now, we need a 2y, a minus 2y. Okay, well, if I put a a plus y here, I get minus 2y there. That's kind of good news. It also gives me an xy, but I need another xy. So maybe if I was to put let me think, what do I want here? I want one of them with 0, and I want one of them certainly with another y term. What have I got so far? I've got the minus 2y. I need a y squared. So if I put a y there, I've got a y squared, and I've got another xy. And it's all worked out beautifully to x plus y minus 2. And you can say, you can then assign your a, b, c, and d values. A is 1, b is 0, c is 1, d is minus 2. And it all looks good. What I like about that question is it makes a lot of sense at the end and everything works out. You can see it in a grid. It's multiplied out correctly. Now, what they've done in part 1 is they've taught us how to do something like this, fully factorize a horrible expression like that. And in part 2, in quite typical step form, they've basically said, okay, now you do it all on your own without any help. We want it into 3 linear factors, yeah? Now remember, there's various hints when you use factor theorem. It wasn't obvious here with this one, but certainly with this one, the factor pairs you should be picking are like, 1, 2, 5, and 10. Probably 2 or 5, because they're probably not going to go boring with 1. And also, don't forget, it doesn't have to be X necessarily. It could be Y as well. And well, you could guess at a lot of things here, plugging in for X or for Y. But I'd be guessing, like as we did X last time, maybe this one's a Y one. Also, they're leading with 6y cubed. I think they're almost nudging you into it. So you've got to have good guesses here. Now, I'm honestly doing this question fresh, but I've done it many times before, so I know that's how I know that it's probably not worth our while guessing at the x's. It is possible for an x value to to do it, but I'm going to guess at let's see, let's say y equals 2. Yeah. Okay, you've got to do this quite quickly in the exam. You're up against the time, so 6 8s are 48 minus 4. I guess as well, if you think about it, because we've got to cancel that 10, the x's and y's, it's only the y terms we need to consider, really. If we look at the x terms, well, let's just get on with it and write it down, actually, because I'm waffling on and I don't think I'm helping you. Minus 42 plus 2x squared plus 12x minus 4xy. Oh, minus 4 times by 2, so minus 8x. Yeah, I'm changing all the y's in. Plus 2x squared. And then minus 5 times by x times by 4, so minus 20x plus 10. Yeah. Now have a look at this. Firstly, we've got 48 minus 4 is 44. 44 minus 42 is 2. And this is why I wouldn't necessarily pursue this for too long, because I would have seen it doesn't cancel the 10 out, and so it's not going to make 0. So let's try a bit more of an educated guess this time. If you know, sometimes just plugging in anything kind of helps you, because you're like, okay, I think I can start working out what I need to do now. The problems here are obviously cancelling some of the x squared terms here. If you look at that x squared term, how are we going to cancel it? Well, it would be nice if maybe like y was minus 2, because that's the only x squared there. We've got to get rid of it. Remember, this has got to go completely to 0. These two, it's just occurred to me, that kind of gives it away, doesn't it? Like, because we've got to have y as minus 2. It's got to be y as minus 2. Let's give that a go. So y equals minus 2. We're going to get, now this time it's going to be minus 48. Let's see if the 10 cancels as well, because that's a problem. We're going to get minus 4 again. We're going to get plus 42. And we're going to get plus 10 on the end. That's nice because they go. Yeah. Now you're going to have your 2x squared, but that's going to cancel with the minus 2x squared over here. Your 12x is there. Now this time you're going to have plus 8x. And over here, you're going to get minus 20x still, and hence, somewhat beautifully, it equals 0, and hence, you know, make it real clear to the examiner once again you've worked out what's going on, hence y plus 2 is a factor. Now, if memory serves, it's actually been a little bit of a while, to be honest, since I've done this question. If memory serves, this one's a bit more of a fiddle to fully factorise. Let's see, though. Let's see. I wonder if I can use the hand thing on the screen to pull this down. Do I need the clicker? Oh, yeah. I just want to pull it down the screen so I've got it freshly displayed, if that's okay. Oh, you just need a fresh screen sometimes without all my scribbles. Okay, so we know y plus 2 is a factor of this, so I'm going to start trying to factorize it, and the reason why I've pulled it down is because I know I'm going to need to draw quite a big grid, because that's quite a long equation. Actually, maybe I'll do it along, that'll probably be more sensible. Yeah, okay, right, here goes, can we do it? Let's try it. Okay, so we've got y plus 2. Okay, straight away I'm thinking, gotta be a 6y squared to make the 6y cubed, tick, plus 12y squared, okay, a little bit disappointing, but not really, because it's like, right, I need to deal with the minus y squared here next. So, okay, maybe if I had a minus 13y here, then I get minus 13y squared, and I can tick that one. Now that's also giving me minus 26y, so I really only need minus 21y, so I guess I need a 5 here, and so I've got a 5y, and therefore I've got minus 21y. That also gives me a plus 10, and I get happy with myself because that looks quite nice. It's almost like I've done part of it. Now what else have we got here? We've got a minus 4xy. I didn't really go straight to these because, well, I suppose I could do the x squared first because it's like 2 there. Okay, I'll do the x squared first. X squared, that gives me 2x squared, but that's also going to give me x squared y. Oh, that's kind of nice because I needed it. And then I need a 12. Have I done the 12x yet? No, I haven't. Well, if I put a 6 here, x, then I get the 12x, and that gives me a 6xy. Now I need a minus 4xy. Oh, let me get my ticking so I get put off if I haven't done my ticking. Yeah, that's good. Oh yeah, I've got just a term on the end basically. Now I really want plus 10 here, so I guess plus 5 should hopefully sort it out. I get plus 10 and I get 5y there, which is somewhat, no, yeah, that's, what am I talking about? I'm looking at 10. Sorry, I'm just going to do that bit again. As you can see, sometimes things go tragically wrong and I kind of lose the thread of my thought. Okay, let's look at this term. I need a minus 5xy squared, so minus 5xy, I guess. That gives me minus 5xy squared, and it also gives me 10xy. Now, Oh, yeah, minus 10xy. And that is perfect, actually, isn't it? I've just noticed, because 6xy minus 10xy is minus 4xy. Phew, we survived. We survived. They do get a bit confusing, those bits. As you can see, I just completely had a clown moment in the middle of that one where I was just suddenly babbling and making no sense. You were probably shouting at the screen in anger. That's fine. Feel free to, get it off your chest. Okay, y plus 2 times by 6y squared minus 13y plus 5 plus x squared plus 6x minus 5xy. Now, we've got a bit of a problem here with this one. This is going to be tougher, there's no doubt about it, than what we just did. And I think this is where it actually gets pretty tricky, because we've got to try and write that, and we can take some inspiration from earlier on in the question. We've got to try and write that as like, a constant times x maybe plus a constant times y plus a number on the end. A constant times x, a constant times y plus a number on the end. Because I mean, there's no guarantee that the same conditions will hold before. We could see that it had to be x and x actually before, because we had an x squared after we'd done our previous factorization. That x squared there meant it had to be x and x on its own. So let's see if we can look at this and have some hints in the same way, because I think this has got some hints. I mean, look, we've got an x squared. If we start with that part, it's going to be the 6y squared where I think we'll have problems, because there's more than one way to factorize 6y squared. Maybe it's y and 6y, or maybe it's 2y and 3y, and that's why that bit makes me a little bit more concerned. So I'm trying to factorize this bit into two linear factors. So let's make a start. We know it's got to be x and x for the x squared. Smashing. We also know we need a 6x. Now, okay, that remember, you're going to do a number times that one and a number times that one. So it's a bit of, there could even be a bit of guesswork here. And I'm going to try and avoid guessing. I wonder if there's any other things I can do straight away. I suppose it doesn't matter which way round I put the 1 and the 5 for 5. 5's fortunately a prime number. So bearing in mind these are supposed to be all in integers, or guess, yeah, if it's fully factorized like that, we regard only expressions where they've got nice integer values as, factorized. That's you wouldn't say to factorize like a quadratic, you'd allow for square roots in there or anything like that. So yeah, we expect whole number integers in factors. But yeah, because of that, I'm thinking, well, I can certainly put the 5 and the 1 in, yeah, and we can put it next. It doesn't matter which order we write these things in. That's going to give me the 5, and I know that's going to be on the end. So I've got that, and it's also going to give me 5x and x, which makes 6x. So it also sorts out that term, which is kind of nice. Now, I'm really avoiding the difficult bit here, but at some point you've got to bite the bullet. Okay, we've got minus 5xy here, but then we've also got like minus 13y to consider and 6y squared to consider. Well, like, I guess minus 5xy, you could get it in lots of ways. You could get it like, you could put like a minus 2y here and a minus 3y here, and that would give you minus 2xy minus 3xy. But we might change this. I might rub this out in a second if it doesn't look like it's going to get us the other terms. So let's have a look. That would also give me a minus 15xy and a minus 2y there, and a plus 30 xy squared. Yeah, oh sorry, 30. What am I talking about? Once again, I think I've just had a clown moment there. Feel free to rage at the screen. Plus 6y squared, I apologize. So it gives us a 6y squared. Cool. It gives us the minus 5xy. But what doesn't look so nice is the minus, well, firstly, I think I've written this wrong. That should be just minus 15y. Look at this. I've had a right old moment and got confused. This should be minus 15y. It gives us minus 17y overall, and that doesn't look so nice, does it? That's not what we need. So maybe it's done in a different way. Yeah, so this is just like a by inspection bit at the end, but that bit messed it all up. So we'll try again. Maybe we should write it down as like 6y minus y. Let's give that a go. That's going to give us minus xy and minus, now let's think about the xy terms, minus 6xy. That's also no good because we want minus 5xy. So that's no good. And I can't just change one of the signs on, yeah, if I was to change this one to a plus, yeah, to make it positive xy, Okay, it looks good now, but the problem is I get minus 6y squared there. So that's not going to be any good either. Bit of a shame. So back to the drawing board, I'm afraid. Now, where are we going to get the minus 13y from? I'm now thinking I want to look at that term and try and make sure that one gets obtained because I feel like we're neglecting it somewhat. Well, the minus 13y comes from these two numbers, the constants here and here, yeah? And so if we have in some way minus 2y there, that would give me minus 10y, and then minus 3y here. I think I have swapped them round from before. That would give me the minus 13y, and then I get minus 3xy here, minus 2xy there. So far, so good. Oh, is this the moment where it all makes sense? I think I've got it. Yeah, that should really be minus 3. I'm thinking in my head and writing down something different. Sorry about that. I do that a lot. I find it really hard to discuss the maths as I do it at the same time when the maths gets to a sufficient level of difficulty. I'm not brilliant at that. But yeah, okay, so now we've done it, I think. X minus 3y plus 5, and then x minus 2y plus 1. That looks to me like it should work perfectly. Okay, I hope you enjoyed that. Yeah, that is the end of the question. I think it is. Don't think there's anything else. Yeah, factorized it into three linear factors. Hope you enjoyed it. Hope it made sense. Hope you didn't mind my mistakes, and well done.